Good morning, ladies and gentlemen. Hope you all are having yourself a wonderful Tuesday morning. Today, we are going to talk about, for our little 5-minute adventure or 5-10 minute venture, we're going to talk about a famous mathematical dilemma, a mathematical question called the prisoner's dilemma. And if you've heard anything about game theory or anything about the prisoner's dilemma, then you probably already know a little bit of what we're going to talk about. But it's mainly a question surrounded by a question about a situation, and based on, okay, what should we do and why is it important mathematically? So, for our scenario, imagine that you and a friend are brought in for some police questioning. Please forgive me, my grammatical errors. Brought in for some police questioning. When you arrive, you're both told that you are guilty of a crime. The nature of the crime is not important, but what is important is that somebody will go to jail. That is one of our assumptions. Somebody is going to go to jail today. Somebody. But obviously the nature of the crime is not important. What is important, okay, we caught you, somebody's going to go to jail today. And it's you and a friend. We put some quotations around friend, because this is not going to be a friendly situation. But the cops give you both some choices, and here we go. Choices. If you confess and turn on your friend, then you are free to go, and they get 3 years in jail. Obviously, since your friend is there, they get the same deal. If your friend confesses on you, you get 3 years, they get to go free. If you both stay quiet, both of you receive 1 year of jail time. But if both of you confess and rat on each other, you both receive 2 years of jail. So these are our 4 choices, or at least our 4 consequences based around 2 choices. Because we really have to start thinking about this in the terms of choices. You have the choice of staying quiet or confessing. Your friend also has the same choice of staying quiet or confessing, but these are the 4 consequences based on those choices. Remember, if you confess and turn on your friend, you go free, they get jail time. If your friend stays quiet, if your friend confesses, they go free, you get jail time. If you both stay quiet, you only receive 1 year of jail. And if you both confess and turn on each other, you both receive 2 years of jail. So, I've done this experiment with my students, or at least I've talked about this experiment. I haven't sent anyone to jail. I've talked about this experiment with my students a couple of times. And all my students say, oh, I'm just going to stay quiet. I'm just going to stay quiet. I'm just going to stay quiet. And typically, out of the 2 students that I pick, one typically stays quiet. It's the other one that confesses and snitches on their friend, and they go free. Well, you might say, well, it either doesn't matter, or, like, it's good to get yourself off, versus, like, okay, I'm willing or not willing to take the other person to jail. Well, I want to let you know there is a mathematical solution to this. There is a mathematical way of understanding, okay, there's a definite right and a definite wrong answer here. But it does kind of go with one of our assumptions. Our assumptions are there are only 2 choices. And this is going to be for your friend, and this is going to be for you. You can either stay quiet, or you can confess. Your friend gets the same option. They can either stay quiet, or you can confess. And I'm going to put this there. The total's there. Because just as it's true that on the assumption that, okay, everybody has 2 choices, the assumption that someone is going to go to jail is also true. There There is no choice that everyone wins. Someone has to lose. And let me fill in your choices blue. If you stay quiet, well, both people stay quiet. If you confess, if you stay quiet while they confess, you get 3. And if you confess, they confess, you both get 2. So you can already see that there are some numbers up here. 1, 2, 3, and 0. But if you confess and they stay quiet, they get 3 years. If you stay quiet and they confess, they get no years. If you both stay quiet, 1, and if you both confess, you both get 2 years. So this is just a handy tool because you can do this with most any logical situation. Like when you're weighing the pros and cons of things, it's actually a pretty good tool to be able to say, okay, I'm going to assign a mathematical value to these things. And the values are obviously, for this, in years. If you both stay quiet, there's a total of 2 years spent in jail. But if you stay quiet and they confess, you get 3 years. So that's 2 years versus 3 years. And I'm going to knock out this total. If you confess and they stay quiet, they get 3 years. And if you both confess, you get 4 years. So if we consider just from totals, and have the idea that, okay, the more years combined spent in jail, the worse the situation is, then the winning play here, or the best case scenario, would be the one that you only get, that only 2 years are spent in jail together. And that only comes from if you both stay quiet. If you both stay quiet, sure, you have to spend a year and they have to spend a year, but that in total is less than everything else. That is only 2 years being spent. And a lot of people might say, oh, that's not a winning move because you have to go to jail. It's like, yeah, you have to go to jail, but that's just 1 year in jail versus 2 years in jail or 3 years in jail. So 1 year in jail versus, think about it like this. Think about it like probability, right? E over T. How many ways do you go to jail? Well, there are 3 out of 4 ways you go to jail. How many ways do you not go to jail? 1 out of 4. And so, most likely, if you consider just the probabilities, most likely you're going to go to jail. Most likely you're going to go to jail. And so, with this, it's mathematically understandable that if it's most likely that you're going to go to jail, the one that gives you the least amount of jail is the one where you both stay quiet. That's a 1/3 chance. So, ladies and gentlemen, it's mathematically supported that you should stay quiet. Don't talk to the cops unless you've got a lawyer. I don't know if I spelled quiet correct. I hope I spelled quiet correct. Get a lawyer. Now, let's talk about some conclusions. That answer seems pretty straightforward. Okay, if you stay quiet, it's the least amount of time. But like the Monty Hall problem, that's not guaranteed. While you have control over your actions, you cannot control the actions of your friend. And when the cops it's often seen like police dramas and stuff like that. When the cops put the squeeze on you, one person normally cracks and takes everyone else down. Ladies and gentlemen, with that, you really, like the Monty Hall problem, while it's not a perfect situation, if you know the math, if everyone knows the math, it's a better way of understanding it. You should be able to say, okay, well, mathematically, it's better if everyone stays quiet for the situation, but I'm definitely going to say that this is not guaranteed. When I did this problem for multiple groups of students, last year I wasn't able to do it with my students this year because of COVID-19. If you do this all the times I did with students last year, I never had one where both people stayed quiet. One person always ratted on the other person. And so it comes down to an idea of, okay, what's mathematically best, what's logically best, or versus what's emotionally best for me. A lot of people go with their emotions, even though it's not the best choice. But, ladies and gentlemen, that's the Prisoner's Dilemma for today. I love it because it's a great idea of game theory. But, ladies and gentlemen, I hope you have yourself a wonderful Tuesday day.